Hello, myself Sri Devi. Today I am going to give a demo on class 10 chapter circles. You are already familiar with the terms like circle, radius, diameter, chord, sector, segment and arc. What is meant by circle? Circle is a collection of all points in a plane which are equidistant from a fixed point. Let us consider points like A, B, C, D on the boundary of a circle, and these all points are equidistant from this fixed point, and this fixed point is called center of the circle. The line segment joining from this fixed point to any point on the boundary of a circle is called radius of the circle. This is radius, this is radius, this is also radius, and this is also radius. This is the center of the circle. So what is meant by chord? Chord is a line segment. Chord is a line segment which is having its endpoints lying on the boundary of a circle. Here PQ is a chord of the circle, and because endpoints of this PQ line segment lie on the boundary of a circle, therefore PQ is chord. In the same way, ST is also a chord. We can draw chord here. Let it be AB. So this is chord. Then what is diameter? Diameter of a circle is the longest chord which passes through the center of the circle. So diameter is the longest chord of a circle which passes through the center of the circle. We name it as Mn. Here Mn is diameter of a circle, and this is 2 times of r, 2 times of the radius of the circle. So these are all basic concepts, but in today's class we will going to learn about the new concept, that is tangent of a circle, and its related one theorem, and that theorem is very important. Tangent of a circle. To understand what is tangent, I will draw a circle and explain. Okay, it's a circle with center O. If a line, that is straight line, intersects a circle at only one point, then this line, straight line, is called tangent of a circle. This line is called tangent of a circle because this line touches or intersects the circle at only one point, and this point is called point of contact. We name it as PQ. PQ is a tangent to a circle. What is the definition of tangent? Tangent of a circle is a line that intersects a circle at only one point. Here PQ is a tangent to a circle, and the point where the tangent touches the circle or intersects the circle is called point of contact. Can we draw only one tangent to a circle? No, we can draw infinitely many tangents to a circle. Here ST, this is also tangent, and Mn, this is also tangent. Like this we can draw infinitely many tangents to a circle. Then we move on to the very important theorem related to tangent of a circle. What is the statement of this theorem? The statement is the tangent at any point of a circle is perpendicular to the radius drawn through the point of contact. Okay, what is the statement of the theorem? The tangent at any point of a circle is perpendicular to the radius drawn through the point of contact. Let's consider a circle. This is a circle with center O. Let us draw one tangent, that is PQ. So, what is the theorem? That is tangent at any point of a circle is perpendicular to the radius drawn through the point of contact. This is the radius drawn through this point of contact. Let this point of contact be S. Okay. So for a circle we have many radii. So this is radius and this is radius. So for particularly this tangent is perpendicular to the radius drawn through the point of contact. That is, we have to prove PQ is perpendicular to OS. That is, makes 90 degree. So what is given? Tangent to a circle. So what we have to prove? PQ is perpendicular to OS. So to prove this theorem, we make construction. This construction. Let P dash be a point on the line PQ, on the tangent PQ. Join P dash to O. Okay, that is construction. Let P dash be a point on PQ and join OP. Okay, see here, if we think logically, we can say OP dash is greater than the radius of the circle. Let it be M. See, OP dash is greater than OM. That is, the length of OP dash is greater than the length of OM. Since OM and OS are radius, OM and OS are radii of a circle, OM is equal to R and OS is equal to R. Therefore, OM is equal to OS. Therefore, we can replace OM by OS. That is, OP dash is greater than OS. If we consider another point P double dash on this line PQ and join OP dash, OP double dash, then obviously this is greater than ON, that is radius of the circle. It is OP double dash is greater than ON. And since ON and OS are radii of a circle, therefore ON is equal to OS. Therefore replace ON by OS. Similarly, if we consider another point, see, take P triple dash by P triple dash on PQ, then join OP triple dash, then this also greater than OS. So if we take any points on the tangent PQ, obviously that line should be greater than OS. So here shortest distance between the point O and the tangent PQ is what? OS. Therefore, we can say OS is the shortest distance between center of the circle and the tangent PQ. Then we can say this is the OS is perpendicular to the tangent PQ. Because shortest distance is the perpendicular distance, we can say PQ is perpendicular to the OS. That is, the tangent at any point is perpendicular to the radius drawn through the point of contact. Therefore, PQ is perpendicular to OS. Hence the theorem. This is the proof of the theorem. Thank you.